So before we begin, we have some new intelligence regarding regarding the enemy compound. Deviant's going to cover that.
So we had some of our intelligence analysts pulling more information for you, because how many people here are interested in trying out to be field agents? Are you going to try to rescue?
Come on, we need more agents.
We need 2 hands. There's a hand. You're going to learn how to pick and shoot and get out of handcuffs. And this is why you need to understand this. We have now looked at a map, and we've identified the facility where our comrade is being held. Now, going over satellite photos, we've been able to determine it's actually a very large compound, very formidable, lots of rooms, but we don't think the main assault will have to be on the compound. Our research indicates, as we said, that there is a Cold War bunker somewhere in the hillside. Now, we think we have isolated where that is. Over the past few nights, it turns out there's local people who've been working with us with long-distance photography, trying to get images of this facility. Now, even though this is an old building, as we heard, the reports were correct. There are modern alarms, modern sensors. This place is hooked the fuck up. A frontal assault is not going to work. But one of our local villagers wandered through the forest. Now, there is a small building up in the woods. We think this is another entrance to the bunker.
We're going to use that as our ingress point.
If you are doing this, if you are the field agent assaulting, be prepared to go down some interesting tubes.
Now, we've analyzed the video that was sent to us.
Yes, you saw the video where they were threatening us, threatening our friend. Remember that? They weren't careful with their camera. There was a little bit of motion and things where they thought they weren't recording, and we found a couple of interesting frames. Now, if you notice, we can enhance, because you know that's how that works, right? We see that they are using networked cameras, so you're probably, if you're the support agent working on the network side, you're going to be working on some network gear cameras. We have another image that, again, we didn't think meant a lot, but when we enhanced, we noticed there are different doors. The coloring, if you saw behind her face when they were shouting at her, green door. We think the pretty girl is behind the green door. So remember that during your assault. More intelligence will be available as you go. What you need to understand about this game is that there are multiple roles you can play. The game is not a single-player game because there is a field agent and there is also a support agent. You two will be in communication all the time with radio. It is the field agent who is physically breaking in. The support agent is going to be network attacking. And you will work together with information that you can each see. The field agent is the one doing attack and assault. The support agent is the one disabling and hacking security. All with the same goal, to get the girl out. We know you can do this. After lunch, the workshops begin, the qualifiers begin, a lot of good times. What are some of the wiring qualifiers?
So the wiring consists of, very simply, we've noticed that there may or may not be a full scalable alarm system deployed inside the bunker. So we want to make sure that you do, whoever chooses to be the field agent has the ability to tap into that alarm panel without cutting and sensing the guard to your location. So we're gonna teach you how to tap into the alarm panel. We also have a qualifier for the exploitation part, in which we will be showing you how to own a Windows box. Not that it's that hard, but we want to make sure that you have the ability on site as the support agent to hack into a Windows box and retrieve either data or get access to the bunker that way.
And be sure to look outside after lunch. Lockpicking, escaping handcuffs, and shooting. The top qualifiers get to choose their own teammate, and you will be the top teams that assault. We want to see people do this.
So to recap.
Yes, this was the facility where we think she's being held, the bunker. We will insert you along the road. You will take a car with your rifle and your tactical gear. We will hike you up the hill along the fence line. And after you attack the bunker and you escape, you have to get to the extraction point. On the far side of the field, that is where we will call in the chopper, and you will climb the ladder to freedom together. All right, now for those of you who want to learn about the alarms that you will need the knowledge, both in this assault game and in your whole life, here's Babak and Keith.
Thanks, Steve. Stand on that side. So this is going to be a pretty interesting presentation, mostly because a lot of this research is pretty new. Keith worked on it a while ago. We'll talk about the history here in a bit. But every minute that we spend with these alarm systems, we're finding out more information. And I apologize for the delay in the talk, but there was some new info that we wanted to integrate into the game here, and we wanted to make sure that was ready in time, and we're going to talk a little about that today. So the title of the talk is Alarmed About Your Alarm System Yet? And the reason that this is interesting, the reason that we feel it's important, is because alarm systems really haven't changed in, what would you say, over a decade?
Yeah, at least that, probably 20, 30 years.
At least that. Around the world, there are only a couple of companies that actually make the alarm hardware. And as it turns out, all the different companies that you see that sell alarm systems, most of them are rebranding hardware. And we'll touch a little bit on some of the most common ones. Are we talking about the model and type of hardware that we're looking at here?
Not really, but we have 2 alarm panels here that if you can tell the difference other than the sticker on it, you'd be hard-pressed.
Yeah.
So they're completely different manufacturers, supposedly, but they're identical.
So to be clear, the systems that we're talking about right now, before we begin, they are modern systems. If you go to a dealer and ask them, hey, I need to secure my Cold War era bunker, this is what they would recommend. We've configured them to factory specification. We've spent a great deal of research making sure that this is all correct, and we're going to be talking about that. So before we begin, this is kind of an interesting photo. Keith, you want to talk a little bit about this? We're geeks, we're hardware hackers, so this is going to, this may seem stupid to you.
Yeah, when I first did this talk, I put up this slide as the opening slide as we were waiting for people to come into the room. And there's a challenge. Somebody needs to come up to me at the end of the show or put their hand up in the questions and answer and tell me what this is. See if you can recognize what that is.
If you're a hardware geek, it'll be pretty straightforward. But if you think you have a guess, come to us at the end. Just let us know. We're curious. So before we get further, papers, please. Who the hell are we? Keith, you want to talk a little bit about yourself?
Yeah, my name's Keith Howell. As introduced, I was an electronics engineer in the British military for 10 years. Used to work for UUNet Technologies. I don't know if anybody in the room remembers them, but they're now Verizon Wireless or Verizon in the United States, but they were still UUNet in Europe last time I checked. And after the dot bomb in the USA, I ended up becoming a professional locksmith and access control installer, which is where I came across alarm systems and was rather horrified at the very poor state that they were in. And now I work as a security consultant and security solutions architect for Assurance Data Inc. in Alexandria, Virginia.
As other people that are not me have already mentioned, I'm Babak Javadi. I like to think of myself as a hardware hacker and professional warranty voider. It just seems more fun that way. I am a security researcher and physical penetration tester. I guess that's what pays the bills, so to speak. But I like to do what I love, and I love breaking things. I am the founder of the Core Group, which, and again, we're just a general purpose security firm. Honestly, I created the company just because I wanted to have a job where I love, where I can do what I love, which is, as I mentioned, breaking things. You might have seen me speak at a couple other places under the affiliation of Tool, or the Open Organization of Lockpickers. If anyone's not familiar, who's heard of Tool before, by the way? Has anyone Okay, so we've got a couple hands. It's a worldwide hobbyist lockpicking organization. If you've never gotten a lockpicking for some crazy reason, it's endless amounts of fun. I can't recommend it enough. It's one of my greatest passions, but that's actually not what I'm here to talk about today. So without further ado, let's get on with some neat little info here. So before we get into the actual nitty-gritty, I think it's important that people understand the background of where a lot of this information came from. A while back, a gentleman named Miguel Sanchez decided to independently reverse engineer the ECP data bus. Now, the ECP data bus is actually the method by which the most common type of alarm system communicates between devices. He actually did write an article about it. It was published in Circuit Seller magazine, article 201, or was it issue 201?
Yeah, it's issue 201
issue
of Circuit
201.
Seller magazine.
Yeah. What was interesting, as we'll touch on here shortly, is he was the first person, as I understand it, to publish serial protocol violations in the ECP bus. ECP, as we'll mention, looks very, very similar to serial, but it doesn't follow all the rules. And he was able to publish a lot of that information. Another super cool guy, Sean Matthews, decided that he wanted to create a hardware device that allowed your computer to interface with your alarm system. So you could have, say, a software keypad, create your own types of devices that interact with your alarm system. So he created something called the AD to USB. Basically, on one end, it's got, and we'll touch on it, it's got an interface that connects to the alarm bus. On the other end, it's got a USB port that you plug into any computer, Windows, Mac, Linux, and it gives you an interface right to the system. Now, to do that, he also did some independent reverse engineering of the ECP data bus. His information not all of it is published, as I understand it. How much has he published, do you recall?
He hasn't published his interpretation of the alarm protocol, the communications protocol.
Right.
So
there's surprisingly very little information about this available out there, which is really fascinating and kind of scary because this standard, again, as we mentioned, has not changed for more than a decade, and it's still being used today.
And this manufacturer that we're working with at the current time, and there are other manufacturers that we haven't yet researched, they have probably more than 70% of the United States alarm market. I don't have any figures for their inroads into the European market.
But they are in Europe and in South America and pretty much everywhere else on the planet. This is a huge, huge hardware vendor. There's a lot of cool forums out there, like the DIY security forums. These are great resources. Mostly it's comprised of people who just want to work on their own alarm system, not a whole lot of technical details. We're trying to change that. So, and then the first public talk that I know of, Keith did at ShmooCon 2012. A lot of the info that we touched on there, we're going to recap here. And that's actually when I got involved. I was so excited by all this really cool information that we decided we kind of go full tilt at it and see how much we can uncover. And we've uncovered quite a bit so far. So before we get into that, Keith's going to talk about some of the initial investigation that was done in figuring out how these alarm systems talk to each other, how do they work.
Yeah, we're going to flip over to the presentation I did at ShmooCon. We've made a few changes, so some of the slides I'm going to just skip past, but we had a severe lack of time to try and integrate all the new material, so we're going to flip over?
To clarify, we're going to show you live. So the live demo, we had wiring problems. We couldn't get it set up here. I see a gentleman with a laser pointer back there for some reason. But during the training, we're going to be able to show everyone how these live alarm systems work. You'll be able to interact with them in person, and you'll see some of the exploits in person working on the alarm panel on the keypad. So we'll get that set up for you after lunchtime.
Flip the other present.
It's in here. It's integrated. Yeah.
Okay, so where do we start? Now, we started looking at the alarm bus, and all of the documentation is all showing... okay. I normally wear spectacles, glasses, I can't see this screen. So we have 4 wires, black, red, green, and yellow. They look fairly similar on the screen here, but that's for the 4-wire bus that goes between the alarm panel and every device, keypad that's wired into the panel through that bus. They're all wired on a parallel bus.
So, I mean, all the hardware hackers here are going to know what that means, but just to clarify, all devices that talk to each other are wired in parallel on the same bus, which effectively, in network terms, that means everything's connected to a hub. Electrically, any signal sent by one device is received by all other devices. It's just that some devices ignore that information. So that's going to be key here.
So when we first started looking at this, we didn't know any data about that bus whatsoever. We didn't know what voltage it was, we didn't know what protocol it was, and in a hardware terms, how do you look at something like that? So what we did was we hooked up the oscilloscope. If you haven't dealt with an oscilloscope before, it has a very high impedance, a resistance on its input. That means that you can attach it to a circuit, and it doesn't affect the circuit as much as like putting a multimeter or a LED or any other type of measurement device across the terminals. And it's really simple to measure. Oops.
There we go.
There we go. So this is a trace, and sorry, it's not coming out very well, but you can see the line here, and then it spikes up. This is part of a transmission on the bus. You can see up in the top corner, we've got 2 volts per division, and on the screen here, we add it up, and we end up with 6.5 divisions. Now, if we do a simple math, that comes out as approximately 13 volts. So we look at it and we think, well, maybe it's RS485. But RS5 uses differential signaling. There's 2 signals, a positive waveform and a negative waveform on separate wires. So what we were seeing on the bus didn't match. And also it's the wrong voltage. So RS422, another serial protocol. Again, it doesn't use differential signaling. And once again, it's the wrong voltage.
So already we're running into the problem of security through obscurity. But obviously it's not very obscure.
Yeah. So RS232, the favorite. But there's no negative voltage. If you look at the spec on signal, you can see that we have a 0 volts, and the signal is from minus to plus. So, oh yeah, all the images, these are all from the Wikipedia pages. If you want to read more about the various protocols, everything's publicly available for all of that. So what now? So, of course, what else am I going to do as a hacker? I'm going to search the internet, try and find something else. And I found a patent, and it's system and method for panel linking in a security system.
Patents are awesome. Is there, but I don't even know, is there a European equivalent for a patent search? Does anyone know? In the US, for people who aren't familiar, you know, you make a new fancy gadget, you think it's pretty cool, you want to make sure no one else steals your secrets, you patent it. And of course, all the patents are publicly searchable, so if you don't care about, say, making your own commercial device, you just care about how it works, you want to hack it, patents are awesome. They have to reveal all sorts of crazy crap in there in order to patent it that you can then use back against the system.
So we go forward. There wasn't much on the protocol, but it had some interesting block diagrams about the contents of the data packets involved. And more reading. By the way, it's not easy looking through these patents because this particular company has probably about 600 or 700 patents that mention the word alarm. They're a very big manufacturer, so there's a lot of reading. This took months of reading patents to try and find some of this information.
By the way, we don't name this manufacturer in this recorded talk right now, not because that we want to necessarily protect this one manufacturer, but rather because this is the only one that we've looked at so far, because it's a huge project. We don't want to single out any one vendor as these guys are bad and everyone else is good. To the best of our knowledge, probably all alarm systems are going to be vulnerable in different respects. But this, if you talk to us, if you see the hardware, obviously you're going to see what's going on. You're going to see the vendor. But that's all it is. We want to be extra clear in that even though all of our research is on this so far, this just happens to be the most popular type of alarm system. So
Yeah, and also some of the problems that we're going to show are not a manufacturer's problem. It's an installer problem. The standard thing that if the installer's idle, lazy, wants to do it fast, they're not going to do the job properly. So in some respects, the weaknesses that we show are also not a weakness in the panel, but a weakness by the installation. So anyway, obviously all of the 3 protocols we looked at, they didn't match exactly. So I go back to the RS-232 spec, and I actually read the IEEE paper on RS-232. And it looks like it's extremely flexible in the way it uses. It's 12-volt tolerant. So let's try a PC. Maybe I should have tried this first rather than looking for something strange, but that's the way you go. So I use a simple program. Has anybody come across miniterm.py, the Python terminal program?
pretty basic, pretty straightforward. We got a couple hands. Cool, cool.
Very, very simple. If you don't use it, it's very simple to use. It's a lot simpler than Hyperterm or any of those.
Woo, Hyperterm. They removed that from Windows. I had to go find it again for an instant.
Terraterm is terrible. So anyway,
That all sucks.
but it comes. It's in the new or in Python 2.6 and onwards. Miniterm is included as a package, as a module, so you can just use it.
So you hook up Miniterm and
So, okay, this is. Thank you, Apple, for changing the standard fonts. So,
it's running Windows.
okay. So here we go. This is very simple. Miniterm options, the port, the baud rate. So just putting in the help file, it just shows you what you need.
You know, it's pretty basic usage. I mean, and spend a little bit of time. All this command line stuff you can figure out easily. I mean, we don't really have to go into great detail here. But the point is that this is a very simple, straightforward program to use. Serial, as you know, only requires 2 pins. You don't really need to hook up a whole lot else. Connect up to it.
So we just put the ground and the receive, and then use this command line. We're just going to go Miniterm. The device I was hooking into the panel uses an FTDI chip, so it shows up as a standard TTY USB port. And the various research I did showed that 4800 was the rate to use. And the live demo isn't going to happen because it takes too long in this particular version.
Well, all the live demos, for time's sake, has been removed from here. We're going to do it in the qualifications and in the training workshops.
But this is the type of screen, this is the screen that you would get, and you can see there's readable text in there. So just hooking up a device with using a standard RS-232 protocol, we get this screen.
Can anyone tell what's going on here? These status messages. This is what you're normally seeing on the keypad. So the panel is actually, it's just using that keypad as a generic display. It's sending it what to display. So that's the data that we're seeing. And what's interesting is it keeps repeating the same thing over and over. So it's always it's super chatty. It keeps talking. And it's always updating the status on all the keypads.
So here you can see, for example, right here and over here, you can see that there's a strange character at the start of the word. We happen to know that this is an S because it reads system. When you look on the keypad itself, you can actually see what it's saying. So what do we do next? Well, we decide to hook up our logic analyzer. But the logic analyzer that I'm using is only suitable for 5 volts. There's now a version that works up to 15 volts, but my pockets aren't that deep. And anyway, reason you want to worry about 5 volts is you do not want to let the blue smoke monster escape. Does everybody know what the blue smoke monster is? Okay, you're all hardware hackers. If you haven't got this badge yet, you will do. It's an initiation rite for hardware hackers.
It's happened to more than a couple of times over the past week.
So the solution's an RS-232 level shifter. This is a diagram from SparkFun. They published this diagram. It's one of the circuits you can use. There was another circuit that was published on the DIY alarm forums. Are you laughing at the ASCII text? It was posted in a forum on a bulletin board forum. Can you read it? It's a winner. So I decided to go the easy way and build a little level shifter. And there we go. So this is the logic analyzer we're using, Salier. There we go. This is the capture that we did. We can show live demonstrations, but this is the capture of the data bus. And you can see all the signals coming in.
Yeah, I mean, today and tomorrow, you're all going to get to play with this. Anyone who's interested, we have all the equipment. If you want to, I want to see what it looks like, live, no problem. We can get it set up for you.
So we want to do some more investigation. So the problem is we only does one read at a time. You read it, you capture it. So we wanted to go a little bit further and monitor both lines. Standard chip, if anybody's come across it, just wiring this up, the max 232. And so there we go. So a little circuit I built. And now, did anybody recognize what that was at the start? Because this is what it was.
Yay, solder shorts.
It's a solder junction. It's actually the flux from the solder. So analyzing the back data, here's a capture. And we're capturing data, but it's still not correct. If you look, you can see a D. You can see the word here with a star, and a star, and a star. But at the star, it comes up as 170. That should also be a star, or an asterisk.
So this has to do with the protocol violations that we touched on.
This is where the protocol violation comes in.
It's not real serial. It's modified.
This is where I came across the research from Miguel Sanchez. And so we go through. And he detailed the protocol violations. And again, more from the DIY forums. This is a device that I came across. This is by Sean Matthews, who we detailed. And it's the AD to USB. You'll see one. We have them hooked up to the alarm panels, and you can see it working. He actually designed a little PIC micro and virtual keypad software, which we'll show in a moment.
That's pretty cool stuff.
It's a standard FTDI chip, and it shows up. So here we go. There we go.
So this is the device. It's very small, very compact, really nice quality, actually. As Keith mentioned, it does come with some virtual software. You can see on here, it's got, the 4 pins connected to the data bus. You've got your data out, data in, positive voltage, and ground. This is the virtual keypad. And you can, you can use it as any other keypad. Your computer basically becomes a keypad, so you can, while you're sitting in your room, whatever, you can over, TCP if you want. You can remote in and, disable, arm, whatever, check status, do whatever you want with your alarm system. It can do anything a normal keypad can do. It interfaces with the EC bus fully. It can handle all of the weird modified serial that it does. You can just type on your keyboard and it'll just send it as a keystroke. And overall, it's very easy to use. Yeah, I will.
Okay.
Now, before I run this, actually, this goes right into another really interesting feature. So, on a computer, if you want to know what particular access a user has, so like John Doe, I want to know what's John Doe's access level. Okay, is he a user? What level of user is he? What can he do? I can't just walk up to a locked terminal and say, please tell me what level is John Doe's user. It's not going to do that. For reasons beyond my understanding, and I have looked around and I don't have any official reasons for why this feature still exists, but on commercial alarm systems, that means the fancy schmancy stuff, from this particular vendor, there is a feature that allows you to check what the access level of a particular user is, just in case you forgot. So if you're not like, boy, code 4257, I don't remember what who 4257 belonged to. I wonder what access level it is. You can ask it that. And then the way you do that is you put in 4257 ** on any panel. And what happens is, if it's not a valid code, it does nothing. If it is a valid code, it beeps, it tells you what partition it's for, it tells you what access level it is. And the best part, there's no brute force detection.
And even better, it does it while the panel's armed.
So that means whether the panel is in an armed or a disarmed state, you can ask it what the particular access level for a user is. Think about that for a second. That means even if you don't have all the stuff that we're going to talk about, you could, over the course of several days, just sit there and go 11111 ** 111112 **. Alarm pins are only 4 characters, no more, no less. They have to be 4 numbers. That's not a very large key space, and you can exhaust that relatively quickly. And with cool toys like the AD2 USB, you can script it and automate it. So let's see what we got here. Hopefully I can... possibly, yes. What the heck? So we're just going to pull up a video of a simple script here. Oh, there. PNG.
Sorry about this. We had a little mess when we switched over computers.
There it is. Okay, so let me pull this over to the other screen here. Now this is sped up a little bit.
It's sped up a lot.
A lot of it. But you can see the clock there. And all it's doing is it's scripting the process of sending keystrokes to the panel. So what you would do by hand, you can have this do automatically. And when it hits a valid code, the panel says, hey, that code is good. It's good. It's good for this.
So you can see here we've got the partition number and the user number, what authority level they are, and this is the information that comes up and shows you.
And remember, the ECP bus, all the devices are connected in parallel. All you need to do is find a wire that connects to a device that needs to talk on the ECP bus, clip into it, leave a device there, battery powered or otherwise, and run a script, interface with it however you want. It's that simple. And to the best of my knowledge, there is no way to disable this feature. I have looked, there might be a backdoor that I don't know about, but there's no easy way to disable this feature.
Okay, so that was vastly sped up. That was a time lapse. The full search of key space that I did there was 399 codes, and it took over 30 minutes in real time. So a full run of 0000 to 9999 takes over 13 hours. But if you've got a device hidden somewhere, say with a radio transmitter attached to it,
which we may or may not have.
May or may not have. What's 13 hours? You could take 13 days if you wanted to.
Right. We only got a couple minutes left,
okay.
So we're gonna have to speed through a couple of this.
Okay.
We originally thought that it might trigger duress codes.
Well, just be careful. If you're playing around with a live panel, there could be duress codes.
Yes.
You could hit a code, and the men in black uniforms show up at your door.
But we have a whole virtualized system that runs independently of any service. So, yeah, as we mentioned, it does work while it's armed. You know, if you come talk to us later, we'll talk about, you know, how you can actually monitor. Remember, again, all the data is sent in parallel to all devices. Not only can you run a brute force, if you don't feel like doing that, you can just sit there and wait for someone to enter the correct number on any keypad and listen to it as it is transmitted in the clear.
This is a shortened version of the keypad, and you can see that this is actually pin number 1, 2, 3, 4 being entered. So there's the dumper, the data bus, 1, 2, 3, 4.
Other stuff that we'll touch on really quick in the workshop. Unfortunately, I apologize. There's so much information to go over. The systems do have wireless sensors that you can enable. And as we found, that information is also sent in the clear. We have some different pieces of really neat equipment that can not only listen to that information, but also spoof it. So you can actually, you know, listen for sensors in an area, and if you wanted to screw with someone, you could, you know, resend that same information over and over, causing that zone to alarm. And imagine in your head, if you have a zone that keeps alarming and you keep inspecting it and nothing's going on, what are you going to do to that zone? You're going to turn it off. You're going to bypass that zone. So this is all stuff that, you know, we will go into detail on in the workshops. There's a lot more work in progress that's happening. This is an ongoing project. There's more coming throughout the rest of the year, not only on this particular vendor, but all other vendors too. So if you're interested in this, please let us know. Talk to us, you know, come talk to us. We want more people working on this. We think it's really awesome. We think it's really exciting. And if any of you guys do as well, we're definitely interested in having, you know, more minds and more hands working on this. As always.
And also, if somebody has information and they want to deliver it anonymously, we're more than happy to accept anonymous donations.
Absolutely. You know, just last bit, remember the 3 R's of security: resist, recognize, recover. Thank you very much.